My dear students, now we are going to study electric intensity at a point on the axis of a electric dipole. Already you know what is the meaning of electric dipole. Electric dipole means a pair of equal and opposite point charges separated by some distance constitute an electric dipole. My dear students, now I will consider electric dipole. See here I will consider electric dipole. This is one charge, this is one more charge. As you know, electric dipole mainly consists of two equal and opposite point charges. That is, this is minus q and this is plus q. And the distance between these two equal and opposite point charges is called what? This is called what? Electric dipole. Electric dipole. Now 2A is electric dipole. Okay, and this is the center O of the dipole. If this is 2A and this is A, getting the idea, and this is also A. In this way, I will name it as EB. EB is our electric dipole. My dear students, see here this figure is representing electric dipole. In this way, electric dipole AB contains two equal and opposite point charges separated by some distance. Here 2A is dipole length and AB is electric dipole. My dear students, you know that the electric dipole is containing two equal and opposite point charges. That's why the total charge of the electric dipole, that is Q, is equal to 0. But electric field of electric dipole is not equal to 0. Why it is like this? Because in between plus Q and minus Q, there is a small distance is there. Because of that distance, the electric field of electric dipole is not equal to 0. But if these two equal and opposite charges are brought in contact, then electric field will become 0. But here there is a small distance between minus q and plus q. That's why electric field of electric dipole is not equal to 0. But total charge of electric dipole is 0. This is very important points that you should remember. My dear students, since electric field of electric dipole is not equal to 0, that means what? This electric dipole is having electric field around it. In this region, positive electric field is there due to the presence of positive charge. In this region, negative electric field is there due to the presence of negative charge. My dear students, in this way, electric dipole is containing what? It is having electric field around it. That you should know. Now, since the electric dipole is having electric field around it, if you consider any point in this electric field of electric dipole, then on that consideration point, if you put the unit positive charge, then that unit positive charge is going to experience electrostatic repulsive force or attractive force. Okay, and that force experienced by the unit positive charge when kept at any point in an electric field of the electric dipole, that is called what? That force experienced is called what? Electric intensity at that point due to a dipole. Getting the idea? ನೋಡಿ ಇಲ್ಲಿ ನಾವು ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಅದರ ಹೆಸರು AB. ಅಲ್ಲಿ ಒಂದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದೆ, ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. ಅದರ ಡೈಪೋಲ್ ಲೆಂತ್ 2A ಇದೆ. ಇಲ್ಲಿ ಟೋಟಲ್ ಚಾರ್ಜ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ನ ನಾವು 0 ಅಂತ ತಗೊಳ್ತೀವಿ. ಯಾಕಪ್ಪ ಅಂದ್ರೆ ಒಂದು ಮೈನಸ್ ಕ್ಯೂ ಒಂದು ಪ್ಲಸ್ ಕ್ಯೂ ಇದೆ. ಹೌದಾ? ಒಂದ್ ವೇಳೆ ಇವು ಎರಡು ಪ್ಲಸ್ ಕ್ಯೂ ಮತ್ತು ಮೈನಸ್ ಕ್ಯೂ ನಡುವೆ ಡಿಸ್ಟೆನ್ಸ್ ಇರ್ಲಿಲ್ಲಪ್ಪ ಅಂತಂದ್ರೆ ಅದರ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ 0 ಆಗಿಬಿಡ್ತಿತ್ತು. ಆದ್ರೆ ಇಲ್ಲಿ ಮೈನಸ್ ಕ್ಯೂ ಮತ್ತು ಪ್ಲಸ್ ಕ್ಯೂ ನಡುವೆ ಸರ್ಟನ್ ಡಿಸ್ಟೆನ್ಸ್ ಇರೋದ್ರಿಂದ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ 0 ಆಗೋದಿಲ್ಲ. ಓನ್ಲಿ ಟೋಟಲ್ ಚಾರ್ಜ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ 0 ಆಗ್ತದೆ. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರೋದ್ರಿಂದ ಈ ರೀಸನ್ ನಲ್ಲಿ ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರ್ತದೆ. ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರೋದ್ರಿಂದ ಈ ರೀಸನ್ ನಲ್ಲಿ ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರ್ತದೆ. ಹಾಗಾದ್ರೆ ಈ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಸುತ್ತಲೂ ಏನಿದೆ ಅಂದಂಗಾತು, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದೆ ಅಂದಂಗಾತು. ನಾನು ನಿಮಗೆ ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೇನೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ದಲ್ಲಿ ಯಾವುದೇ ಒಂದು ಚಾರ್ಜರ್ ಪಾರ್ಟಿಕಲ್ ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನು ಇಟ್ಟರಪ್ಪ ಅಂತಂದ್ರ ಅದ್ರ ಮೇಲೆ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಉಂಟಾಗ್ತದ. ಹಂಗಾರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಅದ್ರ ಮೇಲೆ ಉಂಟಾಗ್ತದಲ್ಲ ಅದಕ್ಕೆ ನಾವೇನ್ ಕರಿತೀವಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್ ಡ್ಯೂ ಟು ದಿಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಕರಿತೀವಿ. Okay, now in this derivation what we are going to do, we are going to derive electric intensity at a point on the edges of electric dipole. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲಿ ನಾವು ಏನ್ ಡಿರೈವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೊರಟಿದೆಪ್ಪ ಅಂತಂದ್ರೆ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಸುತ್ತ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರ್ತದೆ. ಇದು ನಿಮಗೆ ಗೊತ್ತಿದ್ದ ವಿಷಯ, ಹೌದಾ? ಹಾಗಾದ್ರೆ ಅಲ್ಲವ್ರು ಏನ್ ಹೇಳ್ತಾರ, ಎಕ್ಸಿಯಲ್ ಲೈನ್. ಯಾವುದು ಎಕ್ಸಿಯಲ್ ಲೈನ್? ಇಲ್ಲಿ ನೋಡಿ, ಇದು ಎಕ್ಸಿಯಲ್ ಲೈನ್ ಅಂತ ಕರಿತೇವೆ ನಾವು ಇದಕ್ಕೆ. ಓಕೆ, ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ವಾಟ್? ದಿಸ್ ಈಸ್ ಎಕ್ಸಿಯಲ್ ಲೈನ್. ಸೇ ಇಟ್ ಈಸ್ ಎಕ್ಸ್ ಅಂತ ಕರೆಯೋಣ ನಾವು. ಈ ಎಕ್ಸಿಯಲ್ ಲೈನ್ ದಲ್ಲಿ ಪಾಯಿಂಟ್ ಅನ್ನ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೇಕು. ಅದ ನಿಮ್ ಡೆರಿವೇಶನ್. ಯಾಕಂದ್ರೆ ಆಲ್ರೆಡಿ ಹೇಳ್ಬಿಟ್ಟಿದ್ದಾರೆ ಆ ಪಾಯಿಂಟ್ ಎಲ್ಲಿರಬೇಕು, ಎಕ್ಸಿಯಲ್ ಲೈನ್ ದಲ್ಲಿ ಇರಬೇಕು. ಹಾಗಾದ್ರೆ ಲೆಟ್ ಪಿ ಬಿ ಎ ಪಾಯಿಂಟ್, ಲೆಟ್ ಪಿ ಬಿ ಎ ಪಾಯಿಂಟ್ at a distance r. ಎಲ್ಲಿಂದ from the center O of the dipole. See here, let r be the distance of the consideration point P. ಎಲ್ಲಿಂದ from the center of the dipole. Getting the idea? Let P be a point at a distance r from the center O of the dipole. ಎಲ್ಲಿದೆ ಆ ಪಾಯಿಂಟ್? on the axis of electric dipole. ಹಾಗಾದ್ರೆ ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿ 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಇಟ್ರೆ, ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಟ್ರೆ, ಈ ಹೋಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಅದ್ರ ಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಅನ್ನು ಉಂಟು ಮಾಡ್ತದ? ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆಫ್ ದಿಸ್ ಡೈಪೋಲ್ is going to exert a force on that unit positive charge. How much that force that gives electric intensity at a point P due to the dipole, that we are going to derive. ಹಾಗಾದ್ರೆ let P be a point on the axis of electric dipole at a distance r from the center O of the dipole. Now see here, since the dipole is containing two charges, one is negative charge, one is positive charge, then how much intensity is going to produce at point P due to negative charge and positive charge? First we have to find that, and after that definitely we will get the electric intensity at point P due to the whole dipole. Okay, ಹಾಗಾದ್ರೆ ನಾವು ನೋಡೋಣ, ವಾಟ್ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಅಟ್ ಪಾಯಿಂಟ್ ಪಿ ಡ್ಯೂ ಟು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ದಟ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಅಟ್ ಪಾಯಿಂಟ್ ಪಿ, ಎಲೆಕ್ಟ್ರಿಕ್ intensity at P due to positive charge is what? Electric intensity at a point P due to positive charge, that is due to plus Q, is what? E plus Q vector is equal to K into Q divided by, what is the distance between plus Q and point P? Here from O to P it is R, from O to B it is A. Hangara R minus A, it is the distance between plus Q and point P. Hangara na ಏನು ಬರಬೇಕಿಲ್ಲ, R minus A whole square. Okay, call it as equation 1. It acts along which direction? It acts along, ಹೇಳ್ರಿ, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಪ್ಲಸ್ 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಅನ್ನ ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿ ಇಟ್ರೆ ಈ ಪ್ಲಸ್ ಕ್ಯೂ ಅದನ್ನ ಅಲಾಂಗ್ ಪಿ ಎಕ್ಸ್ ಕಡೆ ರಿಪೆಲ್ ಮಾಡ್ತದ ಅಥವಾ ಅಲಾಂಗ್ ಪಿ ಬಿ ಕಡೆ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ತದ? ಆಬ್ವಿಯಸ್ಲಿ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಟ್ ಡೆಫಿನೆಟ್ಲಿ ರಿಪೆಲ್ಸ್. ವೈ ಇಟ್ ರಿಪೆಲ್ಸ್? ಯಾಕಂತಂದ್ರೆ ಇದು ಪ್ಲಸ್ ಕ್ಯೂ ಇದೆ, ನಾನು ಪ್ಲಸ್ 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಇಟ್ರೆ ಪ್ಲಸ್ ಪ್ಲಸ್ ರಿಪೆಲ್ ಈಚ್ ಅದರ್. ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಚಾರ್ಜ್, ಲೈಕ್ ಚಾರ್ಜಸ್ ರಿಪೆಲ್ ಈಚ್ ಅದರ್, ಅನ್ಲೈಕ್ ಚಾರ್ಜಸ್ ಅಟ್ರಾಕ್ಟ್ ಈಚ್ ಅದರ್. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಪ್ಲಸ್ 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಅನ್ನ ನಾನು ಇಟ್ರೆ ಈ ಪ್ಲಸ್ ಕ್ಯೂ ಕೂಲಂಬ್ ಅದನ್ನ ರಿಪೆಲ್ ಮಾಡ್ತದೆ. ಯಾವ ದಿಕ್ಕಿಗೆ? ಅಲಾಂಗ್ ಪಿ ಎಕ್ಸ್, ದಟ್ ಈಸ್ in this direction. This is electric intensity at a point P due to positive charge. It is acting along Px. It is along Px. Okay, getting the idea? Now, similarly, electric intensity at a point P due to negative charge. Electric electric intensity at P due to negative charge is. ಇಲ್ಲಿ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಗಮನಿಸಬೇಕು. What is the direction of electric dipole moment? It is always from negative to positive charge. What is the direction of electric intensity at a point P due to positive charge? It is along Px. Notri. Electric dipole moment ಈ ಕಡೆನೇ ಇದೆ. Electric intensity at a point P due to positive charge E plus Q ಈ ಕಡೆ ಇದೆ. Both are acting along same direction. ಅದಕ್ಕೆ ನಾ ಇಲ್ಲಿ P cap ಅಂದ್ರೆ this is the unit vector which indicating the direction of dipole moment. Here I will take positive sign. Why I am going to take positive sign here? Because E plus Q and P cap both are acting along same direction. That's why I have taken positive sign here. Okay. Now, electric intensity at a point P due to negative charge is what? E minus Q vector is equal to same K into Q divided by. What is the distance of point P from the negative charge? Here O to P is R. From A to A, that is A. ಹಂಗಾರೆ ಮೈನಸ್ ಕ್ಯೂ ಇಂದ ಪಾಯಿಂಟ್ ಪಿ ಗೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಐತೆ? ಆರ್ ಪ್ಲಸ್ ಎ ಆಯ್ತು. ಹಾಗಾದ್ರೆ ಹಿಯರ್ ಆರ್ ಪ್ಲಸ್ ಎ ಹೋಲ್ ಸ್ಕ್ವೇರ್. Getting the idea? Now this is equation 2 and this E minus Q acts along what? In what direction the E minus Q is acting? See here it is minus Q. If I place plus 1 coulomb of charge at point P, then obviously this minus Q is going to attract that, because unlike charges attract each other. Hakadre electric intensity at a point P due to negative charge is taken in this direction, that is along PB. The direction is very important. E minus Q. It is acting along PB. PB. My dear students, these directions are very important when we are going to derive. Okay, it acts along PB. Now one more question is, which is very important. Here electric intensity at a point P due to negative charge, that is E minus Q, is acting in this direction along PB produced. But keep it in mind, what is the standard direction of dipole moment? Standard direction of dipole moment is always from negative to positive. But E minus Q is acting in this direction. In this way, dipole moment and E minus Q both are acting in opposite direction. That's why I will write here P cap. It is the small t P cap. It is the unit vector representing the direction of dipole moment, which is negative to positive. But here one very important thing is, here I will take the negative sign. Why I have taken negative sign here? Because E minus Q and dipole moment both are acting in opposite direction. Dipole moment is along this direction. E minus Q is along this direction. That's why I have taken the negative sign. This step is very important. Okay. Now this is the electric intensity at a point P due to positive charge. This is the electric intensity at a point P due to negative charge, which is acting along PB. Now, what is the net electric field at point P? net electric intensity at point P due to both charges, that is due to whole dipole. See here, therefore net electric intensity at P due to dipole means what? Due to both positive charge and negative charge. Okay, due to dipole is always equal to EP. Vector EP is equal to vector E plus Q plus vector E minus Q, called as equation 3. That is, net electric intensity at a point P is always equal to vector sum of electric field due to positive charge and negative charge. See here, now electric intensity at a point P is equal to vector EP is equal to, what is the E plus Q? That is K into Q divided by R minus A whole square into P cap plus K into Q divided by R plus A whole square into P cap. Here negative sign is there. Okay, now this negative sign is taken on this side. That's why this equation becomes negative. Getting the idea? Here this negative sign is written here. Okay, now see here, electric intensity at point P is equal to K and Q and P cap, all are common, that is K into Q into bracket 1 divided by R minus A whole square minus 1 divided by R plus A whole square into P cap. Getting the idea? Now electric intensity at point P is equal to K into Q. Here LCM is R plus A whole square minus R minus A whole square whole divided by R square minus A square raised to square, that is P cap. Now electric intensity at a point P is equal to K into Q into bracket, here A plus B whole square, that is R square plus A square plus 2AR. Okay, now minus into bracket A minus B whole square, R square plus A square minus 2AR. Okay, now whole divided by, that is R square minus A square raised to square into P cap. Okay, now I will write here. Now electric intensity at the point P, vector EP is equal to K into Q. Here I will write again R square plus A square plus 2AR. Here minus into plus, that is minus R square, minus into plus, that is minus A square, minus into minus, that is plus 2AR. Okay, whole divided by R square minus A square raised to square. Okay, bracket complete, that is P cap. Now R square cancel, A square cancel, 2AR, that is 4AR. Electric intensity at a point P is equal to K into Q into 4AR into P cap divided by R square minus A square raised to square. Here 4AR, this 4AR is going to split. How it is going to split? Electric intensity at point P is equal to K into Q into 2A into P cap, 2A ఈ p cap ఇక్కడ తోడుతుంది into 2r 2a into 2r, that is 4ar, divided by r square minus a square raised to square. Okay, now electric intensity at point P, vector EP is equal to K into, here Q into 2A into P cap. It represents electric dipole moment, which is denoted by capital letter P, into 2R divided by r square minus a square raised to square. Here called as equation. This is 3 and this is 4. Okay, here you must remember that here Q into 2A into P cap represents electric dipole moment, that is capital P. Here R, distance of consideration point P from the center O. This R is greater than small letter a, since R is greater than a, then what happens? The a square is neglected compared to r square. Since r is greater than a, then a square is neglected as compared to r square. Hence equation 4 becomes electric intensity at point P is equal to, K value is 1 divided by 4 pi epsilon naught into P into 2R divided by, here a square is neglected, that it becomes 0, r square raised to square, r raised to 4. Okay, now here 1 r is cancelled, here also 1 r is cancelled, then it becomes what? That is 1 divided by 4 pi epsilon naught into 2p by r cube. This is the standard equation. This is electric intensity at point P due to the dipole. This is the standard expression. Okay, my dear students, and now the question is, in what direction this net electric intensity EP is acting? Obviously, my dear friends, since positive charge Q is very near to P, hence positive electric field is dominant. That's why the net electric intensity at point P is always acts along PX, that is along the axial line. Okay, my dear students, in the previous derivation we have considered the consideration point on the axial line of dipole, but in this derivation we are going to consider the consideration point on the equatorial line. Now we are going to study electric intensity at a point on the equatorial line of dipole. See here, first I will draw the electric dipole. See here. We know that electric dipole is containing two charges. These are the two charges, and this is called what? This is the distance between the two charges, which is called as dipole length. Here two charges are there. First one is, this is minus q, this is minus q, and this is plus q, and I will give the name A and this is B. Here AB is an electric dipole which is made up of minus q and plus q charges. Now 2a, this is the dipole length of the electric dipole. Getting the idea? Now this is called what? This is center O of the dipole. Hence A, this is AO is A and BO is also A, and this becomes 2A. This is our electric dipole. Now the point will be considered here on the equator line. My dear students, this is our axial line and this is our equator line. Now let us draw the equator line. It is we'll draw the equator line here. This is our equator line. Now I will consider a consideration point P here. I will consider a consideration point P here. This is the point of consideration which is lying on the equator line of dipole. Now see here, this is what? This is the distance of point P, distance of point P from the minus q charge, and this is the distance of point P, distance of point P from the positive charge. Okay. Now this is angle theta and this is also theta. See here what we have considered. We have considered an electric dipole AB which is made up of minus q charge and plus q charge, having dipole length 2a with center O. And let P be a point at a distance r from the center of the dipole. Now our aim is to find the electric intensity at point P due to minus q charge, due to plus q charge, that is due to a dipole. Okay my dear friends, already you know that this is called what? This is the axial line. Here this is called what? This is called what? This is also axial line. This is x and this is y, this is x dash. Getting the idea? Now electric intensity at point P due to negative charge is what? See here, electric intensity at P due to negative charge, due to minus q charge is E minus q vector is equal to K into Q divided by what is the distance of point P from the negative charge, that is AP. Here from Pythagorean theorem we know that what is the value of AP. From Pythagorean theorem, if you apply the Pythagorean theorem to the triangle AOP, we will get AP square is equal to PO square plus AO square. Here AP square, PO square means what? PO square means what? This is R square, PO is R, plus AO square is what? That is A, that is A square. In this way, AP square value is R square plus A square. Here what is the distance of point P from the negative charge minus Q, that is AP, and here AP square. AP square value means what? R square plus A square. That is R square plus A square. Okay, now call it as equation 1. It acts along PA. It acts along PA. Why it is PA? Because if you keep one coulomb of charge at point P, then this minus Q attacks the 1 coulomb of charge along PA. That's why intensity at point P due to negative charge is taken along PA. Similarly, electric intensity at P due to positive charge is vector E plus Q is equal to electric intensity at a point P due to positive charge is K into Q divided by here BP square. BP, it is the distance between the plus Q and point P. Hence, according to the equation, BP square value is again R square plus A square. That is R square plus A square. Okay, call it as equation 2. It acts along. See here, it acts along which direction? It acts along BP produced, that is in this direction. In this direction, the electric intensity at a point P due to positive charge, it is acting along BP produced, that is in this direction. Okay, that is BP produced. BP produced. Why it is acting along BP produced? Why it is not PB? Because if you keep the 1 coulomb of charge at point P, then this plus Q repels the 1 coulomb of charge in this direction. That's why in that direction electric intensity is taken. Okay. Now, what is the total electric intensity at a point P due to negative charge and positive charge? That is due to whole dipole. That we are going to calculate. See here one more thing here. From this diagram, you should know that electric intensity, it is a vector quantity. You should keep it in mind. And also here, if it is theta, this is also theta. Okay, if it is theta, this is also theta. Getting the idea? Now see here, here E minus Q and E plus Q both are same in magnitude. Why? Because AP is equal to BP and this angle both are same. That's why they are equal in magnitude. See here, by geometry we have what we have here. AP is equal to BP and angle PAO is equal to angle PBO which is equal to theta. Therefore E minus Q is equal to E plus Q, that is say EQ. Okay, getting the idea? Here E minus Q and E plus Q both are equal in magnitude. Say EQ. Why equal? Because AP is equal to BP and PAO is equal to PBO, that is theta. That's why they are equal in magnitude. See here, hence we will write in general, that is this one both are equal in magnitude. And also keep it in mind, electric field or electric intensity, it is a vector quantity. Here E minus Q, which is equal to EQ. Here this is vector quantity. It is making an angle theta with the horizontal direction, with the x-axis. That's why it is going to split into two components. That is see here it is going to split into two components. That is EQ sin theta along PO and EQ cos theta along PX dash. Similarly, the E plus Q, it is also making an angle theta. If it is theta, this is also theta. Getting the idea? If this is theta, this is also theta. Hence, here E plus Q, which is equal in magnitude, that is EQ, it is also making an angle theta with the x-axis. That's why it is also going to split into two components. That is, in this direction, EQ sin theta along PY, and in this direction EQ cos theta along PX dash. And my dear students, you should keep in mind that here EQ sin theta is acting along PO, that is downward, and EQ sin theta it is acting along PY. Here EQ sin theta is acting along PO and EQ sin theta is acting along PY. Here both are equal in magnitude and their direction is opposite. That's why their net effect at a point P is cancelled, that is 0. But EQ cos theta, these are acting in this direction, that is along PX dash. Both are acting along PX dash. Since they are acting along the same direction, their net effect, their net electric intensity at a point P becomes what? Now net electric intensity at P is, here EQ cos theta, should be added because both are acting along same direction, and that is the net intensity at point P. Okay, that is EQ sin theta plus EQ sin theta becomes what? Net intensity at point P is equal to 2 EQ sin theta, cos theta, 2 EQ cos theta. Okay, call it as equation 3. Here one more important thing is there. What is that? Here net electric intensity at a point P is 2 EQ cos theta because both should be added because both are acting along same direction. Now by this it is clear that net electric intensity at a point P due to both the charges, due to the dipole, it is acting along PX dash. But keep it in mind, what is the direction of dipole moment? It is always from negative to positive charge. This means EP is acting in this direction along PX dash, but direction of dipole moment is along AB, that is negative to positive. By this it is clear that dipole moment and EP, electric intensity at point P due to the dipole, both are acting in opposite direction. That's why here P cap, it is the unit vector which indicates the direction of dipole moment. Here I will take the negative sign here, and this negative sign indicates what? Electric dipole moment, that is P, and electric intensity at a point P due to a dipole, both are acting in opposite direction. Okay, now just simplify it. Electric intensity at a point P, here I will put the vector quantity. Okay, see here. Okay, here is magnitude form. Now what is the value of EQ? 2 into EQ value is K into Q divided by R square plus A square into, okay, what is the value of cos theta? Cos theta is adjacent side, that is A divided by hypotenuse, that is AP. Cos theta is equal to adjacent side divided by hypotenuse. Hypotenuse is AP. AP value is here, AP value is square is R square plus A square, because here there is a square, and AP value becomes square root of R square plus A square. You know this, okay? That is square root of R square plus A square into P cap. This negative sign I will take here. Getting the idea? Okay. Now, electric intensity at point P is equal to minus, I will write K first, and Q into 2A into P cap divided by here R square plus A square, here 1 is there, into here R square plus A square. This should be written like this. Square root of R square plus A square should be written like this. Okay. Now come to the point, that is here what it becomes. Electric intensity at point P is equal to minus K into, here Q into 2A into P cap represents capital P, that is dipole moment, divided by, here this term becomes R square plus A square raised to 3 by 2. Getting the idea? And call it as equation 4. Now here, since R, distance of conservation point P from the midpoint O of the dipole, R is greater than A. Since R is greater than A, then A square is neglected. A square is neglected as compared to R square. Therefore equation 4 becomes what? Electric intensity at point P is equal to minus K value is 1 divided by 4 pi epsilon naught into P divided by, here A square is 0, because neglected means it is taken as 0. Then R square raised to 3 by 2 means 2 cancels, then only R cube remains. This is equation 5. This is the electric intensity at point P due to a dipole, which is point P is lying on the equator line. Okay, this is the expression for electric intensity at a point P which is lying on the equator line due to the dipole. This is the standard equation.